Okay, welcome back to part 2 of the video. Number 5 and number 6 are just asking if ordered pairs are a solution to the system of inequalities. So our first ordered pair is 4 1s. We're going to go over 4 and up 1, and that is sitting in the middle of my shading. So yes, 4 1 is a solution. And then our second one is 0, 5. So out 0 and up 5. And that's definitely not within my shaded area. So it is no, not a solution. So the writing prompt just wants to know how you know if it is a solution or not. I want you to pause your video and write your answer, write in a complete sentence, and then start the video back up and check your answer. Okay, so just make sure that you had both the information about in the shaded region and on the solid boundary line of a shaded region. Okay, so questions 7, 8, and 9 are having you graph your system of inequalities and shade the solution area. So to do that, you're going to have to find the m, the slope, the b, the y-intercept. You're going to have to determine if it's a solid or a dashed line, and if you shade above or below. So go ahead and find all 4 pieces of information and graph each of the 2 lines in number 7, and then shade the solution. I want you to pause your video while doing it, and then check back for the explanation. Okay, as long as you were careful with your solid line and dotted line, and above and below, that one was a very straightforward question. Okay, number 8 is also a very straightforward one. It's already in slope-intercept form. So again, pause your video, find all your information, graph and shade your system of inequalities, and then check back for the solution. Okay, just verify that you got your solid and your dotted lines correct and that you got the shadings correct. Now number 9, again, it's just graphing inequalities, but on number 9, you're going to have to get both inequalities into slope-intercept form first. And the only difference in solving an inequality in an equation is if you divide or multiply by a negative number, you will flip the inequality sign. That's the only thing that could possibly be different. So go ahead and solve both equations or inequalities into slope-intercept form and then graph them. Pause your video to do all this and then check back for the solution. Okay, again, make sure that you've got the dotted line correct and the solid line correct and your shadings correct. Now on number 10, it's actually asking for us to write the system of inequalities that goes with this graph. And just to point out to you, in case you don't quite see it, the y-axis is right here in the middle and the x-axis. So here's our origin. So in order to do this, you're going to need to get the equation for the solid line and the equation or the inequality for the dotted line. And to do that, you'll find your slope and you'll find your y-intercept and write your inequalities. To decide what kind of inequality to put in, you've got a solid line, so you know it's going to have an equals to. And then this one is actually shaded below, so a less than or equals to sign. This is a vertical one. It's a dotted line, so there will be no equals to, and it's shaded greater than, so it's just going to be a greater than sign. So with all that information, go ahead and pause your video and see if you can write the 2 equations, then check back for the solution. Okay, the trickiest part about number 10 was just making sure you remembered how to write the inequality for a vertical line, which is an x equals or an x greater than, in this case, inequality. All right, number 11 takes pretty much a lot of the skills that you already know how to do and just puts them all together into a full situation. So you'll first have to read it and come up with the inequalities that apply to the situation. And once you have your inequalities, then you will graph them and figure out what the solution section is. So I want you to give this one a try on your own. Go ahead and pause your video, give it your very best shot, and then When you are done with that, start the video back up for the explanation. Okay, the biggest thing that I'm sure you noticed on this is you end up with really 3 boundaries. You have the inequality as the total time that they can spend, plus you had some parameters around both the mall and the beach. So it ended up making a triangle for our solution. And then when you're looking at your graph, just make sure you got your solid line correct and your dotted line correct. And then any combination that you can come up with that's in that little triangle in the middle of the 3 lines is a solution. And I put down a couple of examples for you just to make sure that you're thinking along the right lines.